FPE main 200 amp breakers require power to set. The power should be applied to the load side of the breaker. It is not normal for the breaker handles to be floppy. They should have a positive snap when moved to the on position. If you encounter floppy handles, firstly, check for any loose wires or connections. Secondly, inspect the breaker mechanism for any damage or obstructions. Thirdly, if necessary, disassemble the breaker and clean the contacts. If the breaker will not set, firstly, verify that power is being applied to the load side of the breaker. Secondly, ensure that the trip unit is properly seated in the breaker. Thirdly, check for loose or damaged connections between the breaker and the load. The National Electrical Code, or NEC, provides guidelines for the installation and maintenance of electrical equipment. Article 240 covers overcurrent protection, including circuit breakers and fuses. Section 240.4 addresses the protection of conductors against overcurrent. Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. Always refer to the latest edition of the NEC for specific requirements in your area. Circuit breakers are designed to protect electrical circuits from overcurrents, which can result from short circuits or overloads. A short circuit occurs when there is a low resistance path between two conductors, causing a large current flow. An overload occurs when the current exceeds the ampacity of the conductor, typically due to too many devices being connected to the circuit. Circuit breakers have two main mechanisms for tripping the circuit: firstly, a thermal trip, and secondly, a magnetic trip. The thermal trip responds to sustained overloads and uses a bimetallic strip that bends when heated, eventually tripping the breaker. The magnetic trip responds to sudden, high-magnitude short circuits and uses an electromagnet that quickly trips the breaker. When selecting a circuit breaker, it is important to consider the voltage rating, current rating, and interrupting rating. The voltage rating must be equal to or greater than the system voltage. The current rating must be matched to the ampacity of the conductors being protected. The interrupting rating is the maximum short circuit current that the breaker can safely interrupt. Circuit breakers are typically tested to ensure that they meet the required performance standards. These tests include overload tests, short circuit tests, and endurance tests. Overload tests verify that the breaker trips within the specified time current characteristic. Short circuit tests verify that the breaker can safely interrupt a high magnitude fault current. Endurance tests verify that the breaker can withstand repeated tripping operations without failure. Proper installation and maintenance of circuit breakers are essential for ensuring electrical safety. Breakers should be installed in a panel board or enclosure that is listed for the purpose. Connections should be made using the proper torque values to ensure a reliable connection. Breakers should be inspected regularly for signs of damage or overheating. If a breaker trips frequently, the cause of the tripping should be investigated and corrected. When troubleshooting circuit breakers, it is important to follow safe electrical work practices. Always de-energize the circuit before working on the breaker. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, or PPE, such as safety glasses and insulated gloves. If you are not comfortable working with electrical equipment, it is recommended to contact a qualified electrician for assistance. Understanding the operation and maintenance of circuit breakers is crucial for ensuring the safety and reliability of electrical systems. By following the guidelines and recommendations provided, you can help prevent electrical hazards and ensure that your electrical system operates safely and efficiently. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. When dealing with FPE breakers, it is crucial to be aware of their potential issues and limitations. Some studies have raised concerns about the reliability of certain FPE breakers, particularly those manufactured before a certain date. It is recommended to consult with a qualified electrician to assess the condition of your FPE breakers and determine if replacement is necessary. Replacement breakers should be of the same type and rating as the original breakers. It is also important to ensure that the panel board is in good condition and that all connections are properly tightened. Upgrading the panel board may be necessary if it is old or damaged. When working with electrical equipment, always follow safe work practices. To energize the circuit before working on any components. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. If you are not comfortable working with electrical equipment, it is recommended to contact a qualified electrician for assistance. Electrical safety is paramount, and it is important to take all necessary precautions to prevent electrical shocks and fires. By understanding the operation and maintenance of circuit breakers and following safe work practices, you can help ensure the safety and reliability of your electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. The information provided is for general guidance only and should not be considered a substitute for professional advice. Electrical codes and regulations vary by location, so it is important to consult with a qualified electrician to ensure compliance with local requirements.